So we are having three types of resistor and having three different value. One is equal to 4 ohm and resistor is equals to 3 ohm is equal to 2 ohms. So now to connect a 9 ohm resistor in your circuit, right? So how we are going to connect the 9 ohm resistor in our circuit, since we not have a such value of resistor given in our question. We are having 4 ohm resistor, 3 ohm resistor and 2 ohm resistor, right? But we need to connect what? 9 ohm resistor. So what we need to do, let's suppose if we simply add them mathematically, so it will be equal to 9 ohm, right? So but the problem is you already know about the symbol of resistor, right? The symbol of resistor will be like this, a rectangle with two terminals on right and left. Okay, so basically when we are working with three or two or more than two resistors, so basically there are two types of possibility or two different possibilities to connect a resistor. So the first combination is known as the series combination and the second combination is known as the parallel combination, right? Let's suppose if we take the example of students standing in assembly time in the morning in school. So let's suppose if you take the example of a single line of single class, let's suppose if we are talking about the line of class 8 or class 9, let's suppose class 9. So all students are in one line, right? And you observe that if we consider right hand side, so all students have their right hand side on one end and all students have their left hand side on second end, right? And if we consider different classes, let's suppose if we consider our first row, second row. So let's suppose if we are having a class 1, 2, 3, 4, 5, 6. So if we just observe the first student of each column, so you observe that let's suppose one student is standing over here. So this is left hand side, this is right hand side. Okay. And if we consider the second student, so again left hand side, right hand side. Then again a student from next class, left hand side, right hand side. So this will make a combination of left right combination, right? Right is connected with the left of the second student, then again right of one student connected with the left of second student. So this is a type of combination, right left. Okay, but if we observe same students of same class, like another student left on the left side, right on the right side. So if you make connection from these two symbols, so you will get left hand on the left hand side and right hand on the right hand side. So basically there are two possibilities that how we are going to connect resistors, right? Either we are going to connect in series like right left, or either we are going to connect them with same end combination like left with the left end, right with the right end. Okay. So basically there are two types of combination. The first one is in series. Seven. Okay, first of all, we write the definition and study about the basic concept. This combination is known as the series combination, right? Series combination is simply end-to-end connection. You just need to connect one end with the second end, then third end with the fourth, then five, six, and continue, right? That make a series. So in series combination, we just connect resistor end-to-end connections, right? So end-to-end connections, yes. Just like in a single rock, right? Any direction you follow, it's up to. Just like let's suppose if we consider series of any game or series of any movie. So series means that was the first season, then second, then third, then fourth. So let's connect from the first one. So same goes in series combination. But in parallel combination, we are having same ends connection, right? So same ends are connected at one end and the other ends are connected at the second end. You can see that left hand is connected with the left and right is connected with the right one. So same ends are connected. Okay. So that is the difference between series and parallel combination. So these are two possibilities or two types of combination that we can easily make in resistor. Now the question is the same, that we need to connect this 9 ohm resistor in our circuit, and we need to combine these resistors in such a way that we got the value of 9. Okay, so let's suppose we start with series combination, right? If we start with series combination, so in series combination we studied about the Ohm's law, V is equals to IR. You already know about that. So according to Ohm's law, we are having three quantities: potential difference, electric current, and resistance, right? So basically in this part, we are
Okay.
actually finding the value of resistance, right? So
Yes.
basically resistance is unknown, right? So one quantity is already unknown, that is resistance. So R is equals to actually finding R. Now let's talk about the other two quantities, because one of them will remain constant, other one will be variable, right? So other two quantities are the voltage or the potential difference.
Yes.
So let's talk about V and let's talk about current. Okay. Okay. In series combination, so for series combination, let's make a circuit first. Then we will talk about their connections. So let's suppose in series combination, we consider a diagram over here. We are having a connection like this. So all are connected with a battery or a cell like this. Okay, we are not writing the values right now. We are just finding a journal formula. Then we just the values and find the final result. Okay.
Okay.
So these are three resistors R1, R2, R3. All are connected in series combination. So these are their connections. They are connected with each other, and this is the positive and negative terminal. You know that the longest
Yes.
line represents you the positive terminal and the shortest will represent. Okay.
Okay.
Okay, now let's try to figure out that which quantity will remain constant in this combination, either voltage or electric current. Okay, let's suppose if we talk about the value of electric current. So the formula of electric current is the rate of flow of charges, right? Or number
Yes.
of charges flowing in a unit time. And the voltage is actually the work done on a unit charge, or we can say that when a charge is going to be moved from one point or one terminal to the other terminal throughout the circuit, throughout the component, so that will give you the value of voltage, right?
Yes. Yes.
But the problem is when charge starts moving from the positive terminal to the negative terminal, so the direction will be this, from positive to negative, right? Because we studied about the conventional and non-conventional current, right?
Yes.
So
Yes.
this will follow the conventional current. So what do you think, that voltage will remain constant in this situation or electric current?
Current, electric current.
Electric current, because you know that all charges are going to be flow through all resistor, right?
Yes.
Because voltage divides according to each resistor, because we need to resistor, or we need to find the voltage at two potentials, high and low potential, right?
Yes.
So that's why voltage will be variable in series combination, and electric current will be constant throughout the circuit, right?
Yes.
Now let's try to figure out the final expression for this series combination. So starting from the Ohm's law, so you know that Ohm's law is equals to what? V is equals to IR, right?
Yes.
And we know that voltage is variable, right? So our main concern is to find out the voltage, because we are already finding the value of R. Current is already constant, and we are having three resistors, so there will be three voltage and three potential difference for each resistor, right? So if you want to
Yes.
find out the value of V, so it will be equal to the individual voltage of first resistor, individual voltage of second, and then third, right?
Yes. Yes.
So in this way, you can easily calculate the value of V. And now just simply split V with the help of the Ohm's law. So it will be equal to V is equals to IR is equals to IR1 plus IR2 plus IR3. Okay. And we know that,
where is IR? Like same thing as what here.
yes, because we know that V is equals to IR. So we just simply write
Oh,
IR in the replacement of V. Okay.
oh, same, but it means the same thing. The voltage or
Yes, this is for V is equals to IR. Same goes for V1, V2, V3. Okay, and you know that current remains constant, so that's why I not write I1, I2, I3, right? Because current is
yes,
constant, so it remains same everywhere. So we just simply write I. Now we can take common I from right hand side. So remaining value will be R1, R2, R3. Okay. Now we can just simply cancel out this I from both sides. So you will get your final expression, and your final expression is
yes.
equal to what? R is to, in series combination, we are getting our final expression. R is equal to R1 plus R2 plus R3. This is our final expression for series combination. Any confusion?
So resistance equals all the three ones, and resistors you add them, and that.
Uh, it means that in your exam, in your syllabus, there is a term which is related with final resistance, that is known as equivalent resistance, right? We just simply write EQ over here. So this EQ means the equivalent resistors, right? The total resistance.
What again?
Sometimes they ask that find out the total resistance of the circuit, and sometimes they ask equivalent resistance, right? So basically there are two terms. One is known as equivalent resistance, right? So this is important term, because in question they used to ask that find equivalent resistance, or they used to ask the total resistance of the circuit, right? PQ with R, so that will easily give equivalent resistance, right? Let's suppose if they ask that state in a statement, or explain in a statement, that what will be the final resistance in series combination or in parallel combination, right? So for a series combination, we can just
These
simply
two are
write,
just these two are just like you just add all of them together, same
yes,
thing. Right?
we can just simply write that equivalent resistance series combination in series combination will be equal to the
Oh,
equal to
your voice
the
is lagging.
final resistance. Yes, is it clear now? Any confusion?
No, no, no.
Okay, one
It's
more
okay.
thing. You observe that there are three resistor. One is equals to 4, second one is equals to 3, and the third one is equals to 2. If we combine three of them, so you will get a resistance that is greater than the individual one, right? You are
Yes,
getting 9 ohm. So 9 ohm is greater among all the individual resistance. So that is
yes, yes,
also a very important point related to series combination, because sometimes it helps you to write in the paragraph when they ask question, right?
yes.
One more point which we will add over here, that is that the final or equivalent resistance, so equivalent resistance will be greater than the individual. So you just need to know about the combination, that how to combine resistor, And second, you need to know about the formula, and you already know about the SI unit. Ohm is the SI unit of resistance, right? Either we are using in series combination, or either we are using in parallel, or we are using in single resistor, right?
Yeah,
Any
yes, yes.
any question?
No, no.
Okay.
Total resistance is the same thing as equivalent, right? This one.
Is it same for?
The equal resistance and the total is the same thing, right? The same word.
Yes. EQ
Okay.
resistance, equivalent resistance, right? So basically,
Yes.
when we are writing in short EQ, so that is same reference
Uh,
equivalent resistance, right? Okay. If we talk about the parallel combination, so if we talk about the parallel combination, so in parallel combination, we already discussed that same ends combination is known as parallel combination, right? The first thing we need to discuss about that we are finding the resistance. So we need to know about the value of electric current and the value of voltage, right?
yes.
We already discussed. So this time voltage will remain same, right? So current will be variable this time, voltage will be in this time. Okay.
No, why?
Because in parallel combination, I will show you in the diagram that how it is possible. So current is variable, I will show you how it is possible.
Okay.
And voltage will remain same or constant throughout the.
Okay.
Okay, let's suppose if we are having three resistors, over here we are having three resistors and the three, and they are connected like this. Now you can see that all are connected at one point and the other and finally it is connected with the battery. Okay, now we
Yes,
are
yes.
having three resistors, again same three resistor, one, two, now there are two terminals, one over here and the second one over here, right? So when charges starts to move from positive terminal, junction point known as junction, where more than two or more than two connections are going to be combined, right? So when current starts to flow from this junction, so it will divide in three paths, right? Because you know that current will move in circuit same time, it will not move like this. Once it complete round from R1, then R2, then R3, it will move, or charges will move throughout the circuit at same time, right?
Why would they be different?
Yes.
Why would they be different?
Yes,
Like,
so
in
that's
the
why,
equal.
yes, charges will divide equally. So that's why we can say that the current will be different at each end. Because originally we are getting a greater value of electric current, but due to the division in three different paths, so the value of
So they
electric will be variable.
will they be divided equally?
It depends upon the resistor, because we know that resistance is opposite to electric current, it resists the flow of charges. So if we are using a heavy resistor, so that will give you a value of less current. If we are using a low resistance value of resistor, so that will give us a high value of electric current, right? And one more thing about voltage is that now we only have two terminals, one is over here, second is over here. So we just need to find the potential difference. So we just need to take difference from this point and this point. So it will give you a one value of voltage, right? A single value. So that's why voltage remain constant in parallel combination. Okay, is it right?
Yes, sir.
Because we are only having one combination. So due to this single combination, we are only having one value of voltage, but due to different path of electric current, we are getting variable value of electric current. So if we start with again same Ohm's law, so we know that V is equals to IR, but this time the problem is we need to find out the value of I. So I will be equal to the sum of individual value of its current. I1 plus I2 plus I3. And if we want to drive the formula with the reference of I, so I will be equal to V over R, right? From the
Okay.
Ohm's law. So V over R, V over R1, V over R2, R3. So that voltage, that's why we just write V. Again, taking V common on right hand side, that on the other side, so we will R2, 1 over R2, R3. Okay.
Okay.
So this V got cancelled out on the side. So we will get our final equation, and final equation will be 1 over 1 over 1 plus. Okay. So this is
Okay.
our final equation for the. Okay. And you can easily observe that now values are in reciprocal, so it means that we are getting a low resistance if we combine resistors in parallel combination, right? So for a statement we can just simply write it as that the equivalent resistance, this is again our equivalent resistance, so the equivalent resistance in parallel combination is equal to the rest. Now our equivalent resistance is equals to the reciprocal of individual resistance. That's why we write 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over
Why don't we do this in other one? This one over.
YV.
Don't do like this one over V in the before one.
Actually, there is a complete derivation that how we drive this formula, right? It depends upon these factors, that current is constant or not, voltage is constant or not. So we start with the variable quantity, and driving from that we will get the final value, right?
Oh, okay.
That's why I just show you the proof of the formula. I'm just not write the final formula. This proof is not included in your IGCSE. This proof will be included in your AS level, right? So you just need
Okay.
to remember the final yellow cloud formula for series and parallel combination, right? And one more thing
Yes,
related
sir.
to the parallel formula, that is, if we combine all resistance, so your final equivalent resistance will be less than the individual resistance, right? Like this
Yes, sir.
statement, I will also show you by the numbers that we already written that how this values confirm you that either we are writing wrong or right. So your equivalent resistance will be equivalent resistance be less than the individual resistance connected in parallel way. Okay, confusion.
Yes, sir.
Okay, let's try to figure out that actually how it is going to be happen. We consider three resistor 432 ohm, right? So let's suppose if we are having three resistors and we need to differentiate between series and parallel combination. So initially we are having R1, let's see, 4 R2 ohms, and R3 resistor. First of all, let's try the series combination. So in series combination, we know the formula that R is equal to R2 plus R. Very simple. You just uh, add the values, that is the resistance, right? The 9 in series combination, it is very simple, right? It is addition.
plus
Yes. Uh, let's suppose if we want to, so parallel combination, we need to switch the formula first. That is equals to 1 r equal to 1 over r1 over r2 plus 1 over r3. And if we just substitute the values, so 1 over r will be 1 over 4, 1 over 3 plus 1 over 2. Okay? You may just simply solve them in decimals, or if you want to solve in fraction, it's up to you, right? Let's suppose I want to solve in decimals, so I will like 1 over r is equals to 0.25 and 0.33.
if you write a fraction answer to fraction.
Yes, if you want to in fraction, so it's up to you. It will be a same if you want to solve in decimals. So that will give you the same answer too. No confusion, right?
Yes.
So we just simply add these value plus point plus 0.33 plus 0.25. So that is equals to 1.08. So actually 1 over R is equals to 1.08 ohms, right? But this is not our final value, because on left hand side you can see that it is equals to 1 over r. We just need to find r only, right? Not reciprocal. So we need to cross multiply these values. So this will be equal to equivalent resistance will be 1 divided by 1.0. Okay,
Why do
so divided by 1.08. Yes,
why do you do one over?
because this is on left hand side, you observe that this is a value of 1 over r. We actually need to find the final resistance, only r. So that's why we need to shuffle this value to find out the only value of r, right? Just like the series combination, we just simply find the value of r equivalent, not 1 over r. Okay,
Oh, okay.
so that is the problem. So your final answer is equal to 0.9 ohms. And you can see that your final resistance is less than each value of resistance that is given in your question.
Oh
It
yes. Yes.
get the individual one. So this is the proof of your two statements written in your series and parallel combination. Right? Any confusion?
Yes. No, no.
Okay, let me show you some questions that if you want to connect two or more than two resistors in mixed combination. So how you are going to solve that one? Let's try to solve that part.
Can do pencil only?
Yes.
Can I do pencil?
Okay, now this is first question, question number 13. So in this question, you need to find there are three different networks. First one is network S, second one is network Y, third one is network Z. And there are different combinations, right? And you need to find what is the order of resistance of network going from smallest total resistance to the largest. So it means that you
Uh,
need to find
it's B.
equivalent resistance first. Then you are able to find which one is the smallest, which one is greater. Okay.
It's B. It's B.
Which one is the smallest and which one is the greatest or the
No,
largest,
I'm
right?
saying it's B. B.
Okay. So you know that in series combination, this will be the greatest one, right? The 30 ohms.
Yes.
So why is the greatest? So this is the greatest one. It will be in your last option. And what about X? X is in parallel. So you know that it will be least in every
Yes. Yes.
combination, because we observe in our,
It's B, right?
it is the smallest, and it will be in the middle because it consists of parallel and series combination. So X,
B.
Y, Z. Okay.
No, it's Z, Y, right?
XY smallish, sorry, XZY.
Yes.
B.
Here.
Okay. And let's try to solve some other. Okay, now question number 14. Okay, question number 14 is something different. Actually, you need to find out the potential difference across the 2 ohm resistor, right? That is especially mentioned over here on right hand side. They are not asking about the whole resistance or the equivalent resistance. So first of all, let's ignore this part and only consider this specific part, right? And in this specific part, there are only two resistors, right? One is the 8 ohm and the second one is the 2 ohms, right? Now, the first most important thing, you need to identify the combination. What is the combination of 8 ohm and 2 ohm resistor? Is it series or is it parallel?
Series.
Series. So we know that
Yes.
they are connected in series combination. So it means that their final equivalent resistance will be equal to what?
10. 10.
So the final resistance will be equal to, right?
Yes.
8 plus 2 will be equal to 10. This is our final equivalent resistance only for the two resistor because we are only interested in finding the value of 2 ohm, right?
Hello.
Okay. Okay, now what we need to do next? You studied that in series combination, which quantity remains same, current or voltage? Current will remain same in series or the voltage? Current. So the value of electric current remains same in series combination that we already studied in our concept, and this value will be variable. That's why they are asking about the value of V at 22 ohms because they know that current will remain same. And how we are going to find out the value of electric current? That you can find out the value from the total voltage. Yes, I can hear you, but your voice is little bit slow. So I am not able to understand what you are asking about. Okay, so basically in this part, you can take the total voltage that is equals to 18 volt, and you got the value of equivalent resistance of 10 ohms, right? So now using this to electric current first. So I equals to V is 8 is okay.
Okay.
So you will get 1.8 ampere. Current will remain same for both, right? So it
Yes.
is same for R1, that is equals to 0.8. Same goes for R2, 1.8 ohm, right? Now you can easily find out the final value of voltage which is mentioned in the question. So V is equals to I. So actually equals to 1. Current same, and this value will be equal to R2, 2 ampere. So so you will get the answer 3.6.
Okay.
The typical question I know because now we need to combine all concepts, the combination plus the
Why is square it? Why is square it?
square.
Yes, why is square?
Actually, this is only R2 that shows you the resistor number 2. It is not squared. Okay.